Everyone, welcome to this session on AI agents. As project managers and program managers, your ability to lead AI initiatives does not depend on writing code. It depends on understanding how these systems work, how to evaluate them, and how to align them with business goals. In this session, we'll give you some key concepts on how to think about AI agents, what they are, how they work, what you should focus on to make a project successful. Keep in mind, your role is to guide adoption, set the success criteria, and ensure measurable value, not to build the models yourself. So, with that context, let's get started. So, this is what we will look in. First, we'll define AI agents and break down their autonomy level so that you can assess what's fit for your organization or the project you are undertaking. Then we'll look at the technology foundation. What are different large language models, prompting techniques, and tool integration, just some of the basics. And then we'll explore some different advanced agent capabilities like memory systems, dynamic behaviors, multi-agent collaboration, and what that means for scalability. And also we'll cover some implementation guidance on how to evaluate vendors or business, build business cases, manage risks, and drive adoption with best practices. The key is to walk away with actionable steps which you can implement or understand as you run your different AI agent projects. So, what are these AI agents? AI agents are autonomous software systems that perceive the environment, make decisions, and take action to achieve specific goals. This is the definition to remember. So, AI agents are autonomous software systems that perceive the environment, make decisions, and take action to achieve their specific goals. They are different from chatbots, which just respond to user input. Agents can work through tasks end to end with purpose and persistence. Here are the building blocks. A large language model, which acts as the brain to understand and generate language. Tools take action like APIs, databases, or applications your business already uses. Memory systems, so that agent can remember facts, decisions, and context between interactions. And also a reasoning loop to plan steps and adjust as it works, basically to reflect and learn. So, what tasks should this agent own? What tools does it need access to, and what guardrails are required to keep it reliable and secure? Let's look in the upcoming slides. Before that, let's understand what are the different levels of an agent autonomy. So, AI agents don't all operate in the same way. Their autonomy ranges from manual or basic level 1 agents to fully autonomous agents. So, level 1, manual. Every action requires a human approval. Think of an AI that drafts emails, but you still have to hit the send button. Good for some pilots or risk sensitive environments where you don't want to give any control to agents. You go beyond, there are semi autonomous agents at level 2, which handle routine tasks on its own but escalates the complex decisions to a human. And these are perfect for scaling without losing oversight. And then there are level 3, fully autonomous agents. We are not there yet. These run tasks end to end with minimal supervision, like an AI sales agent that researches leads, writes outreach, schedules meetings accordingly. It does everything end to end without any human intervention. We are not there yet. We are still at level 2 and somewhere mid there. And the project manager always asks, what level of control does the project or the user needs demand? What is the approval workflow? And how do we measure success at each stage before moving on to the next? With that, let's move on to the next item. These are the popular LLMs which are currently in the market, segregated into two types. Most agents today are powered by large language models, the LLMs. The hosted options include OpenAI's GPT-4, 5, Anthropic's Claude, which has good, strong reasoning, and Google Gemini. which has the longest context window as of today. Open source options, which include Metaslama, Mistral, Falcon, and so on. These are rapidly improving and often cheaper to run if you have engineering support. Reasoning models and there are also these reasoning models, which take longer time to respond but perform deeper logical steps internally. Like what we have in DeepSeek, it gives the steps in between before generating the complete response. So your decision as a product manager or the one who facilitates these kind of decisions isn't which model to build, it's which one to use and how to evaluate them using real world scenarios or your context before committing. You need to evaluate all these different models to your use case and then typically go with one. So how do you choose a provider and a model? In selecting a provider or a model, these are the basic criteria to look up. One is the context window says how much information it can process at once. Reasoning versus the reasoning quality versus speed trade-offs matter if you need real-time responses. Also the cost per task, not just per token. Check monthly totals against the ROI. Security and compliance, where is the data stored? Is it retained? Does it meet your industry regulations? It's always better to start with hosted providers like OpenAI or Anthropic for fast time to value. You don't need to spend much time on the infra. Run structured evaluations, define use cases, test with the real company data, compare accuracy and cost across models, and document your findings. This is a structured approach which will help you to justify your options and the choices you make as you develop your AI agents. Yeah, let's look at some prompting fundamentals. So prompting, you all would know, is how you tell an AI agent what you expect, and it's as important as selecting the model. System prompts, these set the agent's role, boundaries like an operating system. Example is you are a helpful support agent who answers product questions but escalate billing issues. This is typically tuned into the system, into the context before giving the user generated prompts. These user prompts are day-to-day typical instructions which we give for your team or your customers. And the best practices for prompting is be clear and structured. Use few short examples to show how exactly what good outputs look like. Test prompts in different scenarios to make sure they behave consistently. Guard against prompt injection, where users try to override agents' instructions. They try to retrieve a lot of information from the LLMs. You should define prompt templates and ensure everyone on your team uses consistent tested language to reduce errors. And also there are few basic types of prompting, which is these are three basic types: zero shot, single shot, and few shot. Zero shot, you just ask a question and hope you'll get the best answer. Single shot is you give an example. This is how I want the response to be. Few shot, in the few shot type of prompting, you give multiple examples. In one more approach is ask the LLM itself. I want this so and so kind of output. Help me with a good prompt to give you as an input. That's another way of prompting. You just experiment with multiple different things and see what best works for you. Let's move on to the next item, which is tool calling. For AI agents to be truly useful, they must take action, not just generate some output. This tool integration extends the agent's capabilities beyond what the language model knows. As a PM or one who is facilitating this development, your job is to map business objectives to the tools the agent will need. Think in these categories: data retrieval from databases or knowledge bases, external APIs, weather or stock price or search, internal systems like CRM, email, calendars, content generation. Make a complete inventory upfront of what all different tools you would need. This ensures your agent isn't just smart, it's actually productive with all the tools at hand to use whenever it needs. Here are some design principles for tools. Tools are the agent's hands and feet. How do you design them impacts reliability. These are the four key principles. First is keep tools simple and focused. One tool should do one job well. Smaller modular tools are easier to debug. This is the first principle. One tool should do one job well. Make them reusable. A single knowledge base search tool can serve multiple teams from support to sales. Add error handling and fallbacks. If a database query fails, return a clear error message so that the agents know what to do next. Ensure auditing and security. Log every action, restrict permissions, and verify who can use each tool. Validate that these principles are followed by your technical teams and make them non-negotiable in project requirements. Next is agent memory systems. So memory transforms an agent from a reactive system to truly intelligent. There are two types of memory, short-term memory and long-term memory. So short-term memory stores conversation context temporarily. It disappears after the session. And long-term memory, it stores facts, decisions, and patterns across sessions, typically in vector databases. But memory comes with questions of governance like what should the agent remember for how long, who can access stored information, how will you meet data protection rules. Define policies early. Decide what information stays in memory, set retention periods, and involve legal teams to keep your implementation compliant. There's also this concept of dynamic agents. So dynamic agents adapt their behavior at runtime. They can switch modes depending on the user or the task. This flexibility means they handle diverse tasks without building separate agents for each. They adjust tone and detail automatically from step-by-step instructions to empathetic customer care. They optimize computing resources by loading only when they need. An example would be a customer support agent can shift into technical troubleshooting mode for a power user or a simplified mode for a first-time customer. Your job is to decide when flexibility is valuable and set rules so these changes align with your business voice and compliance standards. Agent middleware. Middleware acts as control tower between your agent and its environment. There are three critical or key components. One is the guardrails. Filter harmful inputs and outputs. Enforce topic boundaries and keep your agent on brand. Authentication and authorization. The second one. Verify users' identity and control which tools or data the agent can access. Third is observability. Monitor performance, log requests, track error rates, and measure user satisfaction. Before going live, insist that these systems are in place. They help you detect issues early, prevent misuse, and demonstrate governance to stakeholders. Third-party integration. Integrating external tools expands your agent's power, but also introduces some risks. Common integrations would include web capabilities like scraping or browsing for real-time information, cloud services connected to AWS, Azure, or Google Cloud for storage and processing, compliance tools, data masking, audit logging, or policy checks. Run a structured risk assessment. Is the provider secure, reliable? What happens if the tool fails? What is the cost structure? Are the terms of service compatible with your organization? Never integrate blindly. Document every dependency and require approval from security teams. This is an important concept, MCP, Model Context Protocol, which is an open standard for how AI agents communicate with tools and with each other. Why does this matter at first place? The first is it provides vendor neutrality, making it easier to switch LLM providers faster or later. Future-proofing, ensuring your agents can adapt new tools without major redesigns. For standardization, faster development. Standardized integration means less custom coding. Encourage your teams to support MCP wherever possible. It reduces lock-in, simplifies upgrades, gives you the flexibility as the AI landscape evolves. Here, some of the key concepts are MCP servers. Tool providers that expose their capability. In case if you're building some application which you want to be used by other applications, you build an MCP server. Or if your application wants to consume data from different tools, you build an MCP client. And also there are these schemas which define the available actions and required parameters for each of these. Next is graph-based workflows. They break down your AI agent's process into clear building blocks as a workflow. Each step is a node, an action, decision, or data transformation. These nodes are connected by edges, creating patterns like branching, chaining, or merging. And this kind of workflow structure gives you the visibility into how tasks flow and control over how agents make decisions. You need to ensure every workflow is documented visually so it's understandable to non-engineers, tested end to end to confirm the branching logic and decision points behave as expected. Graph-based design makes troubleshooting faster and keeps your AI agent predictable. RAG, Retrieval-Augmented Generation. This keeps your AI agent's knowledge current. Instead of relying only on what the model was trained on, RAG chunks and process documents into small, clean segments. It embeds and indexes them into a vector database for fast retrieval. Perform semantic search to find relevant content at query time. It feeds this content to the agent, so it generates answers grounded in real data. This means your agent can stay up to date without retraining. The key question to ask is, what sources of truth must the agent access and how often must they be refreshed? Let's look at some high-level RAG implementation. Choosing the right database is critical for RAG. Define code or fully managed simple API or PV8, Chroma, Milvus. Also decide whether your retrieval pattern will be static, a fixed query flow, or agentic, where the agent dynamically chooses how to retrieve and use information. Common challenges to watch for are hallucinations, stale data, integration complexity with a lot of moving parts. Confirm regular data updates and require test cases that catch hallucinations early. Let's look at what are these multi-agent systems. Complex tasks are best handled by teams, and AI agents are no different. Multi-agent systems divide work among specialized agents, like supervisor agent, who orchestrates the overall process, a research agent who gathers information, verifies information, creative agent generates original content or ideas, and critic agent who reviews outputs, identifies weakness, and suggests fixes. Think of multi-agent system as a digital project team. You need to decide what roles are required, how do agents hand off tasks to each other, what metrics define success at each stage. Multi-agent systems design mirrors like human project management, clear roles, accountability, and coordination. And then finally, let's look at how to evaluate these AI agents. You can't improve what you don't measure, and AI agents need structured evaluation. There are these at high level, there are three methods: textual evaluation, automated, check accuracy, consistency, context handling, and safety. Operational metrics, track latency, cost per task, completion rates. Human in the loop review, assess helpfulness, tone, creative quality, and how well edge cases are handled by someone human. Define success metrics before launch. Schedule recurring reviews to catch drift or degradation. Involve real users early to confirm the agent meets practical business needs. A lot of concepts covered. Let's have a recap. By understanding what all we learned through a implementation. At phase 1, foundation. Define clear use cases and success metrics. Select an initial LLM provider and evaluate all these models. Develop a basic prompting strategy and tool inventory. Move on to phase 2, development. Implement a RAG system connected to your knowledge base. Build middleware for security, guardrails, and monitoring. Develop and test user interfaces. Track milestones closely and make go-no-go decisions based on measured outcomes. And finally, phase 3, launch and iterate. Start small with a limited user group, gather a performance metric, and feedback continuously, refine prompts, improve tool integration, and expand gradually to new use cases. The key takeaway here is start small, measure thoroughly, and iterate fast. The most successful AI implementation grows step by step, providing business value before scaling. And as a project manager, your role is to keep the focus on measurable outcomes, not shiny features which no one uses. Hope this video is helpful. Thank you for watching, and do subscribe to our channel for more such videos. Thank you very much.